In this video, we're going to talk about multiplying and dividing rational expressions. Multiplying and dividing rational expressions is done in much the same way as multiplying and dividing fractions. When multiplying rational expressions, multiply the numerators and denominators and state restrictions. When dividing rational expressions, invert the second rational expression and multiply. When stating restrictions, we need to consider every factor that is a factor of any denominator at any step in the solution. In the case of division, this includes any factor that started in a denominator and ended up in a numerator, or any factor that started out in a numerator and ended up in a denominator, or any factor that started out in a denominator and stayed there. If it was ever at any point, now or in the past, a factor of the denominator, it needs to be considered when stating restrictions. These above bullet points refer to all factors, whether they were eventually crossed out or not. So for instance, suppose we wanted to simplify the situation shown. We could factor the first numerator into 3x minus 1 times x minus 4, and the second and the first denominator to x plus 2 times x plus 2. Factor the first second numerator into x times x plus 2 and the second denominator to x times 3x minus 1. If it helps us, we can bring these all together as one expression because we're multiplying these numerators and denominators together, and we have one long rational expression here. Okay? Now we see that we can cross out 3x minus 1 with 3x minus 1. We can cross out a factor of x with a factor of x and a factor of x plus 2 with a factor of x plus 2. You might be tempted to cross out that factor of x plus 2 with both, but you can't. There's one factor of x plus 2 in the numerator, two factors of x plus 2 in the denominator. You can only cross out one of the factors in the denominator. What that does is it leaves us with an expression of x minus 4 over x plus 2. Okay? And now what we're going to do is we're going to say x plus 2 is a factor of the denominator. We cannot let that equal 0, meaning x cannot equal negative 2. Well, the same factor is here. That's not going to give us an additional restriction. It just gives us the same one. X cannot equal negative 2. There's a factor of x, meaning x cannot equal 0. And finally, there's also a factor of 3x minus 1. If 3x minus 1 isn't going to equal 0, that means x isn't going to equal 1/3. And so what we have is the final statement. Our rational expression simplifies to x minus 4 over x plus 2. X cannot equal negative 2 or 0 or 1/3. Okay, now what if we have the situation shown? Well, we see in the first numerator an opportunity to factor out x and be left with a second factor of x plus y. In the first denominator, we see an opportunity to switch. So we just switch that over. It's not necessary, but that was a preference to do here. In the second denominator, we see an opportunity to use difference of squares factoring. There's no possibility of factoring that first numerator, so we leave it alone. Now, again, there's no possibility of factoring that second numerator is what I should have said. It's x minus 2y, so it remains x minus 2y. Now, let's leave this first, after our first step of our solution, let's leave x times x plus y alone. We're not done factoring yet. Down in our first denominator, we see an opportunity to factor out negative 2x, leaving us with x minus 2y. Our second numerator is x minus 2y, and our second denominator is x minus y times x plus y. And what we see now is an opportunity to cross out x plus y with x plus y, cross out x minus 2y with x minus 2y, cross out a factor of x with this factor of x, because a factor of negative 2x becomes a factor of negative 2 times a factor of x. So showing it perhaps a little more clearly in this one, we cross out this factor of x with this factor of x, this factor of x plus y with this factor of x plus y, this factor of x minus 2y with this factor of x minus 2y, leaving us with a numerator of 1 over a denominator of -2 times x minus y. We can multiply numerator and denominator by -1, and that leaves us with -1 over 2 times x minus y. Okay, well, what are our restrictions? Well, we see right here, where I'm pointing, we had a factor of x in the denominator, so we see x cannot equal 0. Now, right here where I'm pointing, we had a factor of x minus 2y, so x minus 2y can't equal 0, ultimately meaning x cannot equal 2y. We see a third factor of x minus y. Since x minus y can't equal 0, that means x can't equal y. And then a fourth factor here of x plus y. Since x plus y can't equal 0, that means x cannot equal -y. And so our final answer becomes this circled quantity here with the 4 circled restrictions. And that's what's shown on the screen in front of you. When dividing rational expressions, it's important to factor the numerator and denominator of each rational expression. Then invert the second rational expression and multiply. It's important to factor before inverting. Sometimes there's a factor that begins in the denominator of the rational expression on the right side of the divided by symbol that ends up in the numerator. And if we invert before factoring, we miss that restriction that emanates from that factor. So better safe than sorry. We factor, then we invert. So suppose we're given the rational expression division opportunity shown. Well, we factor the first numerator and the first denominator as shown. And then we factor the second numerator and the second denominator as shown. Oops, right here, sorry, as shown. Now that we factored, let's invert. So we're going to change that division to a multiplication, but we have to invert top and bottom, which gives us what we see here. Sorry for all the red written on your screen. But we've all we're really doing, we're just inverting that second fraction to the right of the divided by sign. We're inverting it and changing the divided by to a multiply. Now we're in a position to put the entire numerator together as one numerator, both first and second numerator, since we're multiplying them, and both first and second denominator. Now since we've changed it to a multiplication, we're allowed to push them together, and we have a long rational expression as shown. We cross out factors of 2, cross out factors of x, cross out a factor of x plus 4 with a factor of x plus 4, cross out a factor of x minus 3 with a factor of x minus 3, and we're left with a factor of x minus 7 over a factor of x plus 5. Now, what we do is we look at our possible restrictions. We see in the denominator a factor of x, that cannot equal 0. We see a factor of x minus 3, that cannot equal 0, ultimately meaning x can't equal 3. We see a factor of x plus 4, that can't equal 0, ultimately meaning x can't equal -4. And we see a factor of x plus 5, that can't equal 0, ultimately meaning x can't equal -5. And a lot of times that's where people stop. They state 4 restrictions. They end up losing a mark on the test and they wonder why. Well, here's why. Before we inverted, remember here when I kept on pointing out we're going to invert that? Before we inverted, this x minus 7 was a factor of a denominator. Well, if it was ever a factor of a denominator, we need to consider it with restrictions. So we need to say x minus 7 can't equal 0, meaning x also cannot equal 7. We have that fifth restriction, which you might miss if you invert then factor. So here's me saying that, restrictions. But wait, there's more. The factor of x minus 7 ended up in the numerator, but it began in the denominator, right there. So that x minus 7 can't equal 0, meaning x can't equal 7, meaning our final answer is actually the expression x minus 7 over x plus 5 with the restrictions shown. Now, what if we're dividing as shown here? Well, we're going to factor the first numerator, factor the first denominator, factor the second numerator, factor the second denominator. We're going to change that divided by to a multiply, but we can only do that if we invert the second rational expression, which we do. We can then bring them all together as one, since we're multiplying, bring all those factors together as one rational expression. And then we'll see an opportunity to cross things out, a factor of x minus 2 and a factor of x minus 2, a factor of x plus 3 and a factor of x plus 3. Meaning we end up with a numerator of x plus 4 times x plus 6, a denominator of x minus 5 times x plus 2. Restrictions emanating from x minus 5, meaning x can't equal 5, from x plus 3, meaning x can't equal negative 3, from x minus 2, meaning x can't equal positive 2, and from x plus 2, meaning x can't equal negative 2. But again, we also don't want to miss this x plus 6 right here. We don't have to worry about the x plus 3 because we already accounted for it, but we do have to consider this x plus 6 right here. X plus 6 also can't equal 0, meaning x cannot equal negative 6, even though that factor ended up in the numerator. At one point it was in the denominator. Okay, so it says there x plus 4 was never in a denominator, so it does not create a restriction. That's this one right here. But x plus 6 was, as I mentioned, so we need to consider it. So we have an additional restriction of x can't equal negative 6. And so our final answer is the expression agreed upon earlier with 5 possible restrictions.